So by the end of this comprehensive tutorial, you will be ready to build your very own personalized AI trainer. This tutorial is for everyone because I'm going to start from scratch, and also I'll explain this to the best of my knowledge so that anyone at all who knows the basic fundamentals of the Python programming language can comprehend. If today is your first time visiting my channel, make sure you hit the subscribe button. Also click the like button so that we beat the YouTube algorithm together. You can also consider sharing this with one or two of your friends so that they also learn along. Enough with my self-promotion stuff, let's get right into it and see what we have today. Alrighty, so as usual, we'll look at the prerequisites for this particular tutorial. So first things first, I have this video here, and this is the video file we'll be working on. So this is the exact video we'll be using in this particular tutorial, and at the end of the day, I'll give you the code and the video files and every other files we'll use here so that you can use it and practice with it. So this is a short video about 38 seconds long. So as I said earlier, this is the video we'll be using. Also, these are the requirements. These are the libraries we'll be working with: CVZone and also Ultralytics. So CVZone, if I could spell that correctly, and Ultralytics. All right, I also have this image here, and I'll be using this image to reference some couple of things. So as we are coding along, I'll use this image for some couple of explanations so that you guys understand exactly what we are doing. So the final thing here is the pre-trained YOLO V8 nano version of the post models. Okay, so I'll teach you how to download this model in just a sec. Okay, so these are all the prerequisites we need. The next thing I'll do is to create a new file, and I'll call this main.py. Okay, so I've already installed all these libraries, so you can also go ahead and install it. If you want me to still teach you how to do, just open a terminal, new terminal, and over here just type pip install -r, then requirement.txt. So this will go ahead and install the libraries for you because we have all the libraries in this requirement file. I've already installed this, so my requirement is already satisfied. Okay, so I can kill the terminal, and now we'll go ahead and import these libraries that we've already installed. All right, so first of all, I will import YOLO from Ultralytics. I'll also go ahead and import CV2, which is the OPCV library. By default, when you install Ultralytics, it will install CV2 and also install NumPy. So that's why I didn't add them to the requirement.txt file. So I'll just quickly go ahead and import all the necessary libraries we need now. Alright, so these are all the libraries we'll be needing for this particular tutorial. We'll be using OPCV for reading in our video file and do certain processes on video files. We'll be using NumPy for some calculations, so we'll use it to perform some numerical computations, and then we'll be using CVZone to write some nice looking text on our final output video. So first thing first, you have to try and read this video file in. So to read this video file, we have to create a capture object, and this is called to cv2.video capture. So over here, all you need to do is to type the name of your video file in here. So we have our name here, curl.mp4. So all I need is to just write curl.mp4. So now after reading this, the next thing is to show this video file. So we'll just write a while loop, and I'll call this while true, which is always true. We'll take RT, which shows either we have the video or not, and then we'll now take our video frame, and this will be equal to cap.read. All right, so now after reading this, we just have to go ahead and show it. So if we read the video file, we need to show it so that everyone can see it on the screen. All right, so we use another OPCV function called cv2.imshow, and over here we are going to show this on the frame, and we are going to show our frame. The last function to make this video stay on the screen is the wait key, so cv2.waitKey. And in here, because it's a video file, we'll provide a wait key of 1. If it's an image, normally you put 0 there so that the image will be on the screen. All right, so this is all we need to read in this video file, so we can go ahead and run this code to see if our video file will be read in successfully. All right, so before I even run this code, I'll try resizing the video because the video is very big, so I'll resize it to 640 by 480. so that it will be a little bit smaller. So frame is equal to, we'll use cv2.resize. So it's another function we can use to resize our video frame. And in here, you have to provide a video you want to resize and then follow by the size. So it takes this size as a tuple, and the size we try to give here is 640 by 480. Okay, so this will go ahead and resize this video, and then we can be able to visualize it. So let me quickly run this and let's see what we got. Okay, so we are getting some errors here. Let's quickly debug it and see what the problem is. All right, so I've misspelled the name of the video file. This should be mp4 and I made it mp2. So I'll run this once again and let's see. This time with a little bit of luck, this should pop up our video. All right, so here we go. So you can see our video file playing. So this is simply how you can read in your video file using OPCV. So this is just different videos I've stuck together, and this is showing amazingly on the screen. So this is the first step of this particular tutorial. The next step is to get our model set up. Okay, so we have to read this model and set it up. Okay, so we need a pose model. So for that, I'll come here and write model is equal to an instance of the YOLO we've imported. And over here, we need to type in the name of the model we want to use. So here I'll be using the YOLO V8N, the nano version, which is the smallest one. It's very fast, but it's less accurate compared to the other bigger models like the 8M, 8S, and 8L, which is the large one, of course. So I'll just type in YOLO V8. This should be lowercase. YOLO V8N .pt. Oh, okay, so this is a pose one, so I have to do hyphen pose before .pt. Okay, if not, this will just give me an object detection model. So I type this in, and I've run this code before, so I have the model here. But in case you don't have it, the first time you run it is to go ahead and download it for you. All right, so to demonstrate that, I'll just even go ahead and delete this one. Let me delete it. It's gone. And let me run this code now to see if the model gets downloaded. So you can see straightforward, this has connected to Ultrality's GitHub, and the model is being downloaded. So that's it. You run it, you make sure your computer is connected to internet, and it's going to download it for you straightforward. All right, so it's being downloaded. You can see the same model here, and this is it. So the video is also playing, so we can just quit this. And quick note, it's not mandatory to use the nano version of the model. In case you want to use the smaller version, which is more accurate than the nano one, you can also just type X here instead of N. If you want to use the medium version, which is also more accurate, but it requires higher computation, that means you need a graphics card to run that efficiently, you can put M here. And finally, you can also use the biggest one, which is the largest one here, by just writing L here. In my case, I'll be using N, so the smallest one, which I've already downloaded, so I'll just put it there, and that's it. All right, next step, we need to feed this our feed we are getting our video feed into this model, so that this model can get us the pose key points, and from there we can use these pose key points to calculate the angles and counts, okay, for our AI trainer. So what I'll do here is I will say result is equal to model, and inside this model, just feed in my frame. Okay, so that's it. This is all you need, and this result will return a lot of information for you. But today we are just interested in the key points. Okay, so for that, to get the key points, I'll just do key points, and this key points is equal to result at first in the dot key points dot data. So that's how we can get our key points detected on the body. So dot data at the first index also. So with this, we will get all the key points on the human body. All right, so this is the right time to open up this image. So with what we are doing now, we get all these key points. So you can see the numbers. I'll focus on this particular side of the diagram. We'll get everything here, then number 10, number 8, number 6, and so on. So that's what this will help us to get. We can even go ahead and maybe print these key points. So I'll just write print and I'll print these key points. So let's run this code and see. Okay, so you can see we get, these are the key points. Unfortunately, we are not plotting it on the body, so we can't see it on the body, but I'll do that in a sec. So you can see we are extracting the key points for all the points the model can detect on the human body. So I'll quit this, and what I'll do is to plot it, and to plot it is very simple. So I'll just do frame is equal to results at the first index, which is 0.plot. So when I run this will help me to visualize the key points detected on the body. So let me quickly run this once again, and let's see if we'll get the key points detected on the human body. Okay, so here we go. So over here now you can see we have the key point detected on the human body with even a bounding box showing us that is a person with a confidence of 0.80 something. That's 80 something accuracy. So it's jumping, it's not stable because of the human posture. So we've gotten this, we've gotten our pose points, and that's exactly what we need. So we're on the right track. Now we need to go ahead and extract the points we'll be working with. Okay, so there are a lot of points we are getting, but we need only some few points to work with. So we have to be able to extract only that point, and then we can continue working and making calculations based on that extracted points. So I'll quickly kill this terminal, and then we have to get the points. Okay, so for that, let's visit our image once again, and the point we need here is, let's say, the left wrist. Okay, so the left wrist, the right wrist, we need those points. So in order to get the left wrist, what we need to do is to what is the number 9. So is the number 9 on the hand, and to locate number 9 you can see it's right here. So we have to be able to extract the points here. We also need number 7, we also need number 5, and that's for the left hand. For the right hand, we need number 10, we need number 8, and number 6. So those are the points we need to extract from this particular body. Okay, and with this diagram it will help us to get the index for each and every point. So to get the right wrist, the point number we have to target is 10. So let's see how we can quickly access this particular point. I'll stop plotting, so I'll just comment the plot code over here, and also I'll stop printing the key points. I think we don't need those ones now. So the next thing I'll go ahead and do here is to get, let's say, the right wrist. So to get it, I'll just type right underscore wrist, and this is equal to our key points at that particular index. So our key points at index for the right is 10. So I'll just type in 10 here, and this will help us to get exactly that one. So from the image here, you can see our right wrist is what have the index of 10. So that will help us to access that particular point. And we can do this for all the points that we need. Bear in mind, I told you we need 10, we need 8, we need 6 for let's say our right hand, and for our left hand we need 5, we need 7, and we need 8. So let's go ahead and quickly get all those points. Okay, so to get those points, this is the code we need: right wrist, right elbow, right shoulder. We do it for the left because we are doing this for both hands. Okay, so we need to just get them at their index. So all you need to do is to write the name of what you want, then you use its corresponding index number to access it. Okay, so that's all we need to do to access this particular value. So from the whole body that we are performing post detection, these are the points that we want. Okay, so we have able to what get this particular point. Let's do a little bit of recap. So first of all, we've already in our video file, we display it, then we've set up our model here. Now we fed in our video feed to the model for some prediction. We've also resized our video feed or video frame so that it will be smaller. And over here now we are just getting the key point from the predicted pose point from the model. Okay, so right after getting this, now the next step is to write the code that calculates these angles for us. Okay, so for this we have to do it in object-oriented form so that our code will be reusable. I want us to just develop it using object-oriented programming style, so that next time if you want any part of the body, point for any part of the body to perform some computations, calculations, whatever, you just have to put in the numbers there rather than rewriting the whole code base. Okay, so that will improve our code reusability. So let's go ahead and do that. So for that, I'll come under here and I'll define a class, and I'll call this class angles. Okay, so just let me bring in the class constructor, and this class will take in some points. So we'll give it point 1, point 2, and point 3. Okay, so these are the points that the class will take. And over here, we just have to do self dot point 1. So I'll just type point 1 is equal to point 1, okay, or is equal to p1. I'll go ahead and do this for all the points we've passed to this particular class. All right, so these are the points we'll be working with. All right, and in this class we'll have a method that will be able to unpack these angles for us. Okay, so what I mean by unpacking is that when you take this particular right wrist, it has 3 values. It has the x, the y, and the z value. Okay, so it has 3 numbers, but what we are interested in is the 2 numbers. We need x and y to be able to perform our calculation. We don't need the third value, which is the z value. Okay, so we need to be able to unpack all those values. So we'll define a method in our class that will be able to do that. So I'll call this method unpack angles, and all unpack angles will do is that it will take self, and over here now we'll be able to unpack this particular data. So since it's 3 values, I'll do self.x, self.y, and finally self.z, and is equal to self.point1. So I'll do this to unpack the values into it, and I'll go ahead and do self.x1, self.xy1, and self.z1, and this is equal to self.point2. Finally, we'll do it for the third point. So this will be self.x2, self.y2, and self.z2, and this is equal to point particular 3. Okay, so that's it. So these are our points, and this particular method in our class is taking these points and is unpacking them into what separate variables, so that later on we can use these to perform some actions. Okay, all right, so let's move down. Now we'll define another method which will actually calculate the angles on the hand for us. Okay, so that's the last method we'll define. So we'll just do a df, and this name will be find angles. So I'll call this find angles. Okay, and what it will do is that it will take self, and we just close it up. All right, so in object-oriented kind of programming, we can call one method in another method. So for example, we can call this particular method unpack angles in find angles, so that we'll get access to all its attributes here. Okay, so what I'll go ahead and do is say self dot unpack angles. Okay, I'll just call this particular method here, so that it will allow me to get all the other methods. Okay, so now we first need to do calculation for this particular hand angle, so that we get the points, and then after getting the points we can go ahead and do the angle calculation. So we'll be using numpy for that. So let's say we want the first point, which is v1. We'll do v1 is equal to np.array, and inside this particular array we'll have self.x and self.y for the first point. So we are doing this for the first point, self.y. Okay, and we'll be subtracting this from another array. So this is from np.array. Okay, let me close this so that we can see np.array, and this will be self.x1 and self.y1. Okay, so self.x1, let me cross check, self.y1. Okay, So we'll be subtracting the second point from the first point, okay, so that we can get our v1. And for the v2, we'll do the same thing. So we'll do np.array, and instead of first and second, we'll do the x2. That should be self.x2 and self.y2. Then we'll subtract self.x1 and self.y1 from it. All right, so these are our 2 points. So this will be point 2 and point 1. Okay, so we've gotten our 2 points. We can go ahead and now do our angle calculations. Okay, so this is basically it. So first we need to calculate the angle in radians. So I'll just do angle, and this is equal to, or let me call it angle rad, so that is in radians. So okay, angle rad, this is equal to np.arccos. So we'll be using most of the trig ratios here. So np.arccos, and inside here we'll have a dot product of 0.1 and 0.2. So we'll do np.dot product. So we just do dot, and inside here we'll have v1 and v2. And we are going to divide that by np.len arg dot normalize. Okay, so dot normalize, and over here we'll pass in the 0.1, and we'll multiply it by np dot the same len lag norm 0.2. So I'll encapsulate all of this into square brackets, okay, so that we don't get any error at the end. Okay, I think this is also closed over here. Let me send it over here. That would be cool. Okay, so this is our angle in radians, and the next thing is to convert this angle from radians to degrees. So I'll call this angle in degrees, or angle underscore deg. Okay, so this will be np.degrees. That function is very simple. And over here we just pass in the angle radian into it. So this function will typically take the radians we've computed over here and convert it to degrees for us. At the end of the day, we can return these degrees and we'll use it. Okay, so sometime the post detection will be fluctuating, so we can put this in try and except block so that we don't get our code being maybe breaking if there is no point, or it has not detected the point for us. So for that, I'll just do try, and in try I'll just return angle. So instead of just return it, I'll cast it back to an integer. I don't want floating numbers to, okay, and then I'll do except here, and I'll just pass. So if there is no angle being computed, if there is no degree, it should just pass. It should keep my code running for me instead of just doing something I don't want. So you've seen the nice looking circles on the hand with different colors. Now it's time to write another method in this class that will be able to draw just these circles on the hand, okay, using the points we got. All right, so for that, I'll just define another method. I'll just call it draw circles. Okay, so it will be two methods. We'll have draw circle and draw line. And I think for that one, I'll just copy and paste this code here because it's just cv2.drawCircle and it's the same kind of thing. So I just don't want this tutorial to keep long. I'll paste this here and I'll explain everything. I think this didn't appear well and I need to redo this. Okay, I think this looks good now. So this literally draws circles on the point. So if you want to draw circle, use cv2.drawCircle. You give it your frame, and then we are casting the draw circle function from OPCV takes integer values only. So we are casting the self.x into integer and self.y into integer. Okay, before we use it to draw the circle. Over here we are giving the radius of the circle, and then we give the color, and we want it to fill it, so we just indicate -1 here. So for each particular point, we have about 2 circles or 3 circles on it. So with different colors. So it's just like putting one circle on top of another, but the first circle will have a small radius. The second circle will have a very big radius so that it overlaps the second one. The third one will have much bigger one. So that's what the draw points or draw circles on the hand looks like. Then finally, we also have one that draws lines instead. So this just draw lines that joins the particular circles we have. So when someone is doing, let's say, press up or raising something, you see the lines showing the connecting all the angles together. This particular method is responsible for that. So I'll just paste it to as well. Okay, so draw angle line, and that's it. I've just choose a default color here. I've given it a 3 value, and then over here we use cv2.line, and you pass in self.x, pass in self.y. The rest you just give it your color, which is color we've defined here, and the thickness of that particular line I've chosen it to 6. So you guys can play with it. If you want a very thicker line, you can increase. Very thin line, you can decrease it. Okay, so I think that's it. Now we are done with our class. So this class takes 3 points. We have a method that unpacks the point. We have a method that finds the angle. So it finds it in radian and converts it to degrees. Then we are returning that. We are casting it back to integer. After that, for everything to look fancy on our video file, we are just drawing circles and line. And we have separate methods handling that for us. Okay, so that's all for our class. Okay, now we just have to come and call this class here and use it. And that's the nice part of doing object-oriented programming. All right, so let's test this class out. So for that, I'll come over here, come down, and I'll test it out. So the name of the class is angles, and what angles takes is that it takes 0.1, 0.2, and 0.3. So let's say now we want to find the angle for the right hand. We can just give these points because we've already selected these points. So what I'll do is to give it right. It should take it accordingly, right wrist, then followed by right elbow, finally right shoulder. Okay, so these are the 3 points we need to give to this class in order to work. Okay, but this class returns us something. So anytime you just feed in this particular point, you can see at the latter part we told this class to return to us an angle. Okay, so we have to grab that back. So since this is for the right hand, we'll just do right angle is equal to this. So this will return to us our right angle. All right, so right from this, we need to call some of our methods we've defined in the class. So we have a method that will compute our angle for us and unpack those things. So for the unpacking, we are calling it right here, but for finding the angle, we need to call it so that it will go ahead and find the angle for us. Okay, so at the down here, I can just do that. So for the right one, what I'll do is the right hand angle is equal to, then we'll just do right angle dot find angle because we have a method that finds the angle. Okay, so this will help us to get the angle for the right hand. Okay, and if you want those circles to be drawn, you can just still do the right angle dot draw point circle, right angle dot do draw angle line, and that's it. So right angle dot draw circles, that's all. This doesn't take any parameters. We'll just do the same thing for the other one. So right angle dot, this will be draw line, right? So we did it for draw a circle. This will be draw lines, and that's it. Okay, this takes in nothing. So with this now, our angle will be returned to us over here. So the angle for the right hand will be returned to us over here, and this is just to draw those fancy looking circles on the hand. So I can quickly print the right hand angle, and let's see. All right, so we've written a lot of code. Let's test it. The moment of truth. Let me run this and let's see if everything works or we'll get some error. Okay, here we go. we have it running. So you can see for the right hand now, we are able to get the points, and you can see our code is running. You can see the fancy circles. So we need to do the same thing for the left hand. And then after getting for the left hand, we'll be able to display this angle on the screen and also count if we have a completed maybe power up or power down. We can count based on that. So we are one step closer to the project. So let's close this up and do that quickly. All right, so we'll do the same thing for the left hand. So for that, I'll just put it there so that it's basically the same approach. So I'll just put it right here for the left hand also. So this is the same thing for the left hand. For the left hand, it's applying your left wrist, left elbow, and left shoulder. And we have all those things here. Then this will return to you the same left angle. And over here, it will just draw the circles and the line just as we did for the right one as well. Okay, so from here, the last step is to count, okay? Count the number of successful shoulder abs or whatsoever we are doing. So that's the next step. So let's do that. To be able to count, we need to initialize some variables right here. So we have to initialize counter. So I'll call this counter left or counter L, and this will be equal to 0. We'll give it an initial value of 0. We'll do the same thing for counter. No, this should be counter and not count. My bad. We'll do the same thing, counter underscore right, which is counter R, and it's also equal to 0. All right, from the counters, we will need directions as well. So direction, so we need direction R and direction left. So direction R is for the right hand, direction L is for the left hand. So that I just writing RLL for simplicity. So that should be direction underscore L, and all these are 0. Okay, so these are the variables we need, and with this we can write the logic for the counting. All right, so over here to count, I'll put it in the try and accept block, so that when we encounter any form of error due to unavailability of some of the points or the angle, we will still continue. Okay, so we've implemented that in our class. We've defined here that okay, if there is no angle, you need to what? Pass. Let our code continue running. The same way now we are coming to display the angle. So if there are no values, we need our code to continue running. In next frame, we'll probably get some values. So I'll put this in try, and in try, we'll just first do this for the left hand. So we'll say if our left hand angle is greater than or equal to 100. Okay, so if our left hand angle is greater than equal to 100, this is what we are going to do. We'll also check if the direction L is equal to 0, which we know is already equal to 0. So that's the logic. We'll check direction L. If direction L is equal to 0, and bear in mind we know it's equal to 0 because we've set it 0 here. So if these two cases are true, that means the person have completed one maybe upper raise. That's 100%. He has raised the bar to his upper limit, so we need to count. Okay, so in that case we'll do counter L and we'll give it half. Counter L plus or equal to 0.5. okay, so that's it. We'll give it half, and then we'll reset the counter L direction. Okay, so we just do direction L now is equal to 1. Okay, so the reason why we are doing this is that we don't want someone to just raise the thing halfway, then we count. We have to check if it's up and also is down. So that's why we are putting all these check. So now we've checked for up, we have to also check for down. I'll just do another if, and I'll check if the left hand angle is less than or equal to 70. So probably the person is coming down. So it's less than or equal to 70. You can reduce this threshold based on the type of video you are using. So if that's the case, I also check if the direction L is equal to 1, which I've reset it right here to 1, so I know it's 1. So I'll do if direction L is equal to 1, which I know is 1, then I'll add another 0.5 to it. So counter L is equal to plus or something 0.5, and then I have to reset the direction to 0 once again. So direction L is equal to 0. Okay, so with this logic, we'll be able to count both upwards and downwards. So when the person raises it up and is not able to go down, we will not give the person the full count. We just put this in except we are going to what? Pass. That's it. So this is the logic for counting for the left hand, and it will be the same logic for counting for the right hand. We just need to change the variables. Okay, so we just have to just change all of these to the same thing as this. So I'll just try and paste that in once and for all so that we don't have to rewrite all of this. It's the same thing. Okay, so we have this setup for the left hand and this for the right hand. Okay, so now it's time to display this on our video feed. So that's the final thing, to display this so that we can visualize it, and that's the main reason why we've imported and installed CV Zone. So we have CV Zone here, and we'll be using CV Zone to display all those things. So we just have to display it, and for that, quickly I'll paste that code because those things are very simple things to do. So I'll paste that code in, and I'll just pass you through what each and every line is doing. Okay, so this code is literally for displaying things on the screen. So we use cvzone.putTextRect, that means text rectangle. And for the first thing, we are putting our frame here, which is our video feed. We are using f string here, and we are putting our angle value. So here, this L stands for angle L, so the angle on the left hand, and we are putting the real angle value here because we are using f string. All right. So over here, we are giving it the position in this particular list. So we want it to be on the x-axis 11, on the y-axis 33, giving a border of 2, scale of 2. That's it. And then for the second one, we are putting the left hand counter. So now we have the angle displayed. We will have to put the counter there. So is it 0, 2, 3, or 1? So you can see we are doing it here. And pay attention, the only thing that is important here is that we are casting the counter to int. So we are casting it back to integer value because we'll be getting 0.5, 1, 1.5, and so on, because at each point we are just adding 0.5. So for that, we have to convert it or cast it back to integer so that will count if only there is a successful hand raise both in both upper and downwards or lower direction. So this is what we did for the left hand. We do the same thing for the right hand, and the last thing we display here is our YOLO V8 pose, because we are using YOLO V8 pose from Ultralytics to do this. So that's also being displayed at the corner. So this is the final part of it, and I'll just go ahead and run this, and let's see if everything works as expected. Okay, so we have some error on line 91. So angles here, object has no attribute find angles. Angles here has no attribute find angles. So line 91, let's see if we can debug that. Line 91, left hand angle, because left hand angles dot find angles. So let me see. So first we need to get the angles from our method, and then here we use this left hand angle dot find angles. Okay, so this should be dot find angles. Okay, not angles, it should be dot find angle, right? Because that's the method we've defined. The name of the method is find angle, I think so. So let me cross check the name of the method here, which is find angle. So it's not s, it's only, there's no x attached to it. So that's it. So let me quickly run this once again, and let's see if this time around we are going to get some fresh error free. Coding comes with error. Your ability to debug them makes you makes you what? You can put that in the comment section. Hooray, guys, and here we go. So you can see this exactly what we are displaying. This is the right angle, so that means the left angle is being raised, and we can see whatever is going on here. So my computer is extremely slow running this because I'm running this on CPU. So you guys that have GPU can enjoy a lot of speed, I think. And this is all for this particular tutorial. Maybe in future tutorial, I'll try my best to do this in the web so that you guys can have access anywhere. We can host it. Anybody can have access anywhere to maybe just open the cam and start doing some exercises and getting the counts in real time. I think that would be cool, right? That would be very cool. So guys, this is it. This is simply how to program your very own AI trainer. So that's it. Thanks for watching. If up to this point you are still watching, that means you've learned a lot already. So smash the subscribe button and also smash the like button, share, and do your best to join our Discord channel as well, so that if you have any errors, any questions, other pros there can attend to you. Myself, I will attend to you. Thanks for watching, guys, and I'll see you in another tutorial.